Hello there. This practice exercise is now on the relationships that could be drawn from the angle pairs formed by a transversal. But before we go and dig deeper on this practice exercise, I need to give you a very important caution, right? These relationships, starting with this video, are only possible if we do have a claim in this given figure that the lines cut by a transversal are parallel lines. In this case, in this given figure, line T is considered to be a transversal line as it cuts, passes, intersects two different lines, line E and line F, at two different points. But if there is no given that they are parallel lines, we cannot actually solve any of the measurement here. Probably we could solve others, but not necessarily all, right? So since we have a claim here for this practice exercise, we can now use any of those relationships. We have five relationships in our module, one of which is a postulate, the other four are theorems, which we already have proven. So we can use any of them. But which of those relationships could be used in this given example? In this given problem, you're asked to solve for the value of the variables x, y, and z. But we don't have a given here which is in numeric form. Say for example, my point is if this is actually 80 degrees, then we can solve the rest because one of the eight angles formed by a transversal line here is given to be with a numeric value. But since the given has the numeric value, we can now resort to looking at the relationship with those angles having the same variable. I'm talking about this angle here and this angle here. They have the same variables. So our first key here is to establish relationships between these two angles. After we could establish the relationship between these two angles, we are now to choose out of those five special relationships I have been mentioning earlier, one postulate and four theorems. After we have established the relationship between these two angles, we can choose one of those five special relationships that could be used to solve for the value of x. So this angle here and this angle here are found on the same side of the transversal line. So we have five pairs of angles formed by a transversal line, one of which is corresponding. Next is alternate interior. Next is alternate exterior. The next is same side interior and same side exterior. But out of those five pairs of angles, two are not anymore possible here. Why? The pair of alternate interior and alternate exterior requires the two angles to be found on opposite sides. But since these two angles are found on the same side, these two angles could either be corresponding, could either be same side interior or same side exterior. Only those three possible pairs. No more chance for alternating angles, either exterior or interior. So out of those remaining three possible pairs, let's examine here. If we talk about same side interior, both angles should be found in the interior, but one of which is this angle, is found on the exterior. Not possible. If we talk about same side exterior, two angles, those must be found on the exterior. But this angle here is in the interior. So not also possible. The last pair of angle which is could possibly be established here is that these two angles are forming corresponding angles. So they are corresponding angles. Let me type it here. Corresponding angles. Now that we are sure they are corresponding angles and we are already given with this relationship here, we can now use one of the five special relationships given in the form of postulate, which is actually concerned on corresponding angles. It is the CAP or the corresponding angles postulate. The corresponding angles postulate tells us that if two parallel lines as given here are cut by a transversal line, then the corresponding angles formed are congruent. If we talk about congruent, they have the same measurement. So with the use of this, again, what we did here is first we established relationship between the two angles having the same variable. Sir, why do we use the same variable? Because if we are going to use, say for example, these two angles here, we'll be having an equation with two variables. And if one of which, if neither of them are given with numeric value, we cannot solve them. That is why we're going to settle with angles having the same variables, and that would be these two angles again here. Then we establish that we have that they are corresponding angles, and we are going to use the corresponding angles postulate again, which tells us that the two angles here are congruent or have the same measurement. If we talk about same measurement, the value for 2x minus 30 degrees must be equal to the value of x plus 45 degrees. This is now what we are going to use to solve for the value of x. We came up with this equation with the use of the corresponding angles postulate after we have determined that they are corresponding angles. And out from this, it's just simply solving linear equations. So we are going to start by adding 30 both sides, that 30 degrees rather, right? So that would be 2x is equal to x plus that's 75 degrees. Okay, that's the first. Then we subtract x both sides. Let me use this. This is subtraction. Now we have x is equal to 75 degrees. Right? Now that we have this value, we need to show if it's correct or not. And how do we show that if it's correct or not? We could always do checking. Now, checking is not necessarily required in any of your submissions later on or in your work, but definitely it's an important skill. So we are just simply going to substitute that's 2 times 75 degrees minus 30 degrees must be the same. Checking requires us to make sure that both sides of the equation are equal. So let me place here question mark. That's 75 degrees plus 45 degrees. 2 times 75 is 150 degrees minus 30 degrees. On the other side, still question mark. 75 plus 45 degrees is 120. This side will return to 120. And now that they are equal, that's the right time that we can say this is the correct value for the variable x. So again, we use this equation from these relationships here, solve the value for the variable, and apply a short checking, and that's it. We are done. To answer the remaining variables y and z, we just also need to look at, since we already have value for x here, we could actually solve for the values of each of the angle here. Let's try first before solving y and z. So that would be in the 2x minus 30 degrees when substitute by 75. That's 2 times 75 degrees minus 30. It's actually part of the checking here earlier. That's 150 degrees minus 30 degrees. That's 120 degrees. And as for x plus 45 degrees, substitute the value of x to be 75 degrees plus 45 degrees. That's 120 degrees. As you can see, using the same value for the variable x, we have the same value, and it satisfies the corresponding angles postulate that the corresponding angles here have the same measurement or congruent. The other purpose of doing this is again by in solving values of y and z. So let's look at y, angle y. Angle y here, right, can be solved if we are going to choose the relationship between this angle here and the angle x plus 45 degrees. Right? What do you think is the relationship between angle y and the angle with the measurement x plus 45 degrees? In this example, or in this problem here in number 2 and even in number 3, we may go back to the other angle pairs we have learned in the previous lesson. Specifically, the concept of angles forming a linear pair and angles forming vertical angles. Because if we are going to relate it with this, it will be easier for us to solve the remaining values. As for the variable y, this variable and the angle here which measures x plus 45 degrees are vertical angles. And using the vertical angle theorem, the vertical angles are congruent. Again, congruent, or they must have the same measurement. So we can just simply equate. Let me place here a little bit down. So we can equate the value of y to the value of its vertical angle, which is x plus 45 degrees. Now you could actually attack this item in two different ways. Number one, you could always substitute the value of x here as we have solved earlier, so that when you substitute here, you can now solve for the value of angle y. Or we could always use here, this value is already solved here. X plus 45 degrees is already given to be 120. So the final answer for the value of angle y is x plus 45, which is given to be 120 degrees. Again, this is also the purpose for these items here added earlier. So again, how to solve for the value of angle y? Look at the relationships that could be drawn with angle y and any angle containing the value of the variable x that we have solved already earlier. Do not use the relationship of y and z because none of them are given. We may have problems, bigger problems later. Now for angle z, right? Angle z could be paired with this angle here, right? Angle z and this angle, which is actually measured to be 2x minus 30 degrees, are forming a linear pair. So earlier we used angles and vertical angle theorem. Now angle z and this angle which measures 2x minus 30 degrees are forming a linear pair. And by linear pair postulate, if we are going to add their measurements, it should sum up to 180 degrees because angles forming a linear pair under linear pair postulate are supplementary. And if we say supplementary, they must sum up to 180 degrees. So if we're going to do that, z plus 2x minus 30 degrees must be equal to 180 degrees. They are linear pair because they are forming they if they will be combined, this they form the side here of line E, which is a straight angle, so 180 degrees. Now if we have this, again we could attack it in two ways. One of which is we could always substitute the value of x in this area here and then solve for z later on. Or we could always use this item that we have already given earlier using the same value of x. So if I'm going to continue this one, this is z plus 2x minus 30 is given to be 120 degrees, 180 degrees here. And then solving for z, subtract 120 degrees both sides. The result for angle z is now 180 minus 120 is 60 degrees. So we have solved the measurement of angle z and measurement of angle y after we have solved the value for the variable x. So it's a little bit of a chain reaction. You solve for the value of x first as it is the variable, not necessarily x, but if this is actually the variable that is present in two different angles, which is actually established with this relationship. Okay. So after we solve for x, we can solve for variables y and variable z. But again, very important, do these steps here, identify the relationships, and the relation between the angles and the statement or the supporting theorem or postulate, we could actually tell us about their measurements. Bottom line again, we could always do all of these things if we have this claim here. If we don't have this, then we cannot solve any of these measurements here. Okay, that's a bit of a reminder. So please review this video, and if you might see similar problems like this, you may do the same steps. See you in the next video, next pair of angles for my transversal, and the next relationship of measurements. Goodbye.